Okay, class, today we're going to talk about triangle types. What's on the board right now should be a review. Angles or triangles are classified by their angles and their sides. So first we have the angles. They're right, acute, and obtuse. Can anyone tell me why right angles, there can only be one in a triangle? Yeah.
Because if you had like more than one of each angle, then it would be more than 180 degrees, and that's not a triangle.
Right, so triangles have 180 degrees as tenacity says, and if right angles are 90 degrees and you have two of them, then that's already 180 degrees and you don't have any room for your third angle. So same with the obtuse because it's even bigger than a right angle. So we can only have one of those in each of the triangles, but acute is small enough that we can have three of them in a triangle and have it work perfectly. And then equilateral, scalene, and isosceles are listed below. The hash marks mean that they are equal sides. So what we're going to do today is talk about how you can combine these two categories, angles and side length, and come up with even more triangles. So we're going to do a chant to help you remember all of this review, and then we're going to go into the activity. So if you guys would repeat after me for this chant, we're going to start. Triangles are classified by angle and side.
Triangles are classified by angle and side.
Let's share what we know and share it with pride.
Let's share what we know and share it with pride.
Knowing angles becomes of use.
Knowing angles becomes of use.
They are acute, right, and obtuse.
They are acute, right, and obtuse.
Okay. Next is isosceles with two equal sides.
Next is isosceles with two equal sides.
Scalene is not routine.
Scalene is not routine.
Its sides have three different lengths, as we have seen.
Its sides have three different lengths, as we have seen.
Equilateral is as it sounds.
Equilateral is as it sounds.
Three equal sides, we've got it down.
Three equal sides, we've got it down.
Great, so now try to remember this as we go into our activity. In a minute, but not yet, we're going to stand up and we have a grid, so you're basically going to classify it by like how you can put these together and what the triangle would look like. So we're going to do one example first. Does anyone want to pick, let's have someone throw out an angle and someone throw out a side.
Right.
Right, okay, what else?
Isosceles.
Isosceles, okay, so we're going to do a right and isosceles. If it is both of those, what characteristics will it have? Andrew, do you know?
Is it gonna have 90 degrees
Okay.
and two sides the same length?
Two sides the same length, right, that's perfect. So it's going to have both of those. So first we have two sides that are the same length, and those two sides create an angle that is 90 degrees. So that's what this would look like, and that's just an example. So we're going to work together, work with a partner. When you go up here, you can ask me questions, and we're going to take these shapes and put them on and see if we can get them right, and we'll talk about ones that are maybe mixed up a little bit. So let's go ahead and grab the shapes. All right, go for it. How you doing, tenacity? So remember, isosceles is two equal sides, please. So we have isosceles, and then does that angle look like it's more than 90?
Yes.
Yeah, so that'll be obtuse then, right?
Yeah.
Oh, but this is missing. Okay, so let's see if we can switch it around a little bit.
Okay.
Yeah, so we'll talk about this once we sit back down. This would be right here. So go ahead and put that up. Two equal sides, please. There you go. Good. Okay, so let's go ahead and sit back down. We were a little mixed up at first, so let's talk about it. We had that there wasn't anything for an isosceles obtuse, but actually it can happen as we see here. So the categories are that it has to be one obtuse angle, so bigger than 180 or bigger than 90, and two equal angles, and that is shown there. We can also draw another example. So here, this angle is obtuse, it's bigger than 90 degrees, but these are also the same length, and we can connect it, and we have a triangle. So that is why there is an answer here. But there's not anything here because equilateral triangles all have to have angles that are less than 90 degrees. So we cannot have a right angle or an obtuse angle in an equilateral triangle. And this is because if all of the lengths are the same side, then the corresponding angles all have to be the same too. And like we talked about, we can't have more than one right or obtuse angle. Does anyone have questions? Or does that answer it? All right, good job guys, that was a great activity.